This video is going to talk a little bit about simplifying rationals. It is highly suggested that you have a piece of paper and you work these problems along with me because math is a skill. Like basketball, you can't just watch people do it and know how to do it. You need to get that muscle memory yourself. So, simplifying rationals just refers to simplifying fractions. In elementary school, you learned how to simplify fractions. So let's say we had the fraction 54 over 36. To simplify this fraction, we want to think of common factors that they both have. So I know that 54 is 9 times 6. And I know that 36 is 6 times 6. Let's break these up into smaller factors too, because we might be able to cancel out more than that. We're going to get it into its prime factorization. So 9 is the product of 3 and 3, and 6 is the product of 2 and 3. Down on the bottom I have 2 and 3 for 6, and I have 2 and 3 for the other 6. So now in order to simplify our rationals, what we need to do is cancel out any common factors. So I see I have a 3 on the top and the bottom. They become 1, so I can cancel them out. I have another 3 and 3 on the top and the bottom, so I can cancel those out too. I can also cancel out a 2 and a 2. So it looks like my simplified fraction is 3 left on top and 2 left on the bottom. So let's try another one. Let's say we had 15 over 100. Again, I'm going to think about the common factors they have, and you can do this with prime factorization too if you want. So 15 is 5 times 3, and 100. I could go into the prime factorization of this, but I see 5 and 3 on the top, which means I'm going to start with 5. 5 times 20. From here we can kind of see that all we're going to be able to cancel out are the 5s. So when we cancel out the 5s, we're left with 3 over 20. There aren't any other common factors between 3 and 20, so I can say I'm done. My finalized simplified fraction is 3 over 20. How about negative 20 over 10? This works out so that I have negative 1 times 2 times 10, and then I have 10 times 1. I know I didn't go into prime factorizations, but again, we're thinking about the common factors. That's what we want to cancel out. So 10 and 10 can cancel out. You can cancel out the 1s, but you can't cancel out the negatives, so I'm going to keep the 1s up there. I have negative 2 on the top, and I have 1 on the bottom, which actually just reduces to be negative 2. Simplified the fraction. How about 13 over 14? We go into the prime factorization. Let's just start with the numerator. 1 times 13. Well, that means I'm not really going to be able to cancel much out. So I'm just going to leave the bottom as 1 times 14. You can cancel out the 1s, and you can see that this fraction is actually already simplified. 13 over 14. Can't simplify it. There's no other common factors. So this is just sort of an introduction to what we're going to be doing with our rational functions. These were all numbers. Now we're going to look at some fractions that have x's in them. So here's the first rational expression we're going to factor. I know it looks a lot more complicated than the ones we just did with numbers. We're still going to approach them the same way. We're going to start by looking at the factors of the numerator and the factors of the denominator. You guys should be familiar with factoring from some of your earlier projects. If we're going to factor the numerator, we're looking for numbers that multiply to be negative 6 and add to be positive 1. So that works out to be x plus 3, and that works out to be x minus 2. Same thing for the denominator. Numbers that multiply to be 15 and add to be 8. Well, that would be x plus 3, and that would be x plus 5. Just like we did before, we're going to look for common factors because we can cancel them out. because same thing on top, same thing on bottom equals 1. So I see that I have x plus 3 on top and x plus 3 on the bottom. Those are common factors, which cancel out. So now it seems like what we're left with is x minus 2 and x plus 5. Now we're done. That's actually the full simplification. Can't cancel anything out. It's really tempting to want to cancel those x's out. You can't cancel things that aren't all together. That's not, x minus 2 is the whole factor. So you can't just cancel the x and the x, which means we have to leave our answer as x minus 2 over x plus 5, which is perfectly fine. That's a nice simplified fraction. You'll see later on when we do other things with fractions that you won't mind having both those binomials. So here's another one to look at. Again, I'm going to start by factoring. That's always your first step, whether you're dealing with numbers or whether you're dealing with bigger polynomials. Again, I'm going to think, okay, what multiplies to be 4 and adds to be 5? In this case, it works out to be x plus 1 and x plus 4. In the denominator, I'm going to do the same thing. What multiplies to be 20 and adds to be 9? Well, that would be x plus 4 and x plus 5. Now, look for common factors. Do you see a factor on top and a factor on the bottom that are the same? In this case, we have x plus 4 and x plus 4, so they cancel out, which means our final solution is just x plus 1 over x plus 5. Again, do not be tempted to cancel out those x's. You cannot cancel them out. We have to keep them there. You can only cancel out full factors, not terms. So we're done. X plus 1 over x plus 5 is our simplified fraction. This one's a little bit different. I only have binomials, which means I can't factor like I was doing on the other two examples. We can still factor it a little bit though. When you have these binomials, let's look for a greatest common factor. So when we look at the numerator, I see that 2 goes into 2 and 10, and x can be taken out of both of them as well. So 2x is the GCF of the numerator. When I factor that out, I'm left with x plus 5. Now let's look at the denominator. I have 3x squared plus 15x. So 3x is the GCF in this case. When I factor that out, I'm left with x plus 5. Now remember, we're canceling out common factors. Factors are things that are multiplied together, not added or subtracted. So since x plus 5 is totally on top and x plus 5 is totally on the bottom, I can cancel those out. I also have another common factor, the x's. I can cross those out too. So what I'm left with is 2 over 3. Can't simplify that fraction any further, so I'm done. In this case, we could cancel out those x's. We could cancel these guys out because they weren't being added and subtracted with anything. They were unique terms. They were unique factors in this problem. Remember, factors are things that get multiplied together, so we could cancel them out in this case since they were being multiplied, not added or subtracted with anything. Let's remember our rules. We have to factor first before we can cancel anything out. When we look at the top is actually already factored. We cannot simplify p plus 4 anymore, so it stays p plus 4. The denominator, the bottom, can be factored further. I'm looking for numbers that multiply to be 8 and add to be 6. So in this case, I see that I have p plus 4 and I have p plus 2. Now, common factors is what we can cancel out. P plus 4 is an entire factor on the top. It's 1 times p plus 4. So I can cancel that out from the numerator and the denominator. So now when I go to write what I have left, on the denominator in the bottom, I have p plus 2. And I know it looks like I have nothing left on the top, but we really do have 1 times p plus 4. So I still have a 1 on the top. This is still a fraction. So 1 over p plus 2 is my simplified form of this rational expression. Here's another kind of weird one. So I'm going to start out thinking about factoring. And I'm going to start with the denominator because to me it's looking like the numerator doesn't really factor at all. So I have 15a minus 15. When I factor out the GCF, I end up with 15 times a minus 1. 9 stays on top. Now, don't think that you're totally done yet. I know you're looking there going, I can't simplify that any further. Remember what we did earlier. Earlier we looked at the prime factorizations of numbers. So let's think about these two. 9 is 3 times 3. 15 is 5 times 3. And then we still have the factor of a minus 1. So you can see that we actually can simplify this a little bit further. We can cancel out a 3. So when we get down to our final solution, we have a 3 on the top, we still have the factors of 5 and a minus 1 in the denominator on the bottom. Now 3 and 5 don't simplify any further, and a minus 1, there's not 1 on top. So I'm fully finished simplifying my rational. This one's kind of interesting. I'm going to start out in the way I normally would, and I would factor the numerator and factor the denominator. So again, I'm going to think about GCF. 10x and minus 6, or negative 6, they have a GCF of 2. So if I factor out the 2, I'm left with 5x minus 3 in the numerator. Now let's look at the denominator, 10x minus 6. Again, I have 2 times 5x minus 3. Now we can start canceling common factors. 5x minus 3 is a common factor. 2 over 2 is a common factor. Now, it's not that we have 0 left. Remember, when we're canceling out factors, we are making a fraction of 1. Or same thing on top, same thing on the bottom. So this actually works out to be 1 over 1, which is 1. Done. I could have done that from the very beginning. If we look at this fraction that we had the same thing on the top and the same thing on the bottom. Whenever that happens, you just have 1. Yay! Here's another big one to factor. Again, these are trinomials, so I'm going to factor them my usual way. I'm going to think of factors of things that multiply to be negative 15 and add to be negative 2 in order to factor the numerator. So multiplies to be negative 15, adds to be negative 2. I'm going to end up with x minus 5 and x plus 3. In the denominator, I'm looking for things that multiply to be positive 5, but add to be negative 6. Because of this fact that they're multiplying to be a positive, but adding to be a negative, I know that both my numbers are going to be negative. So both my factors are going to be x minus something. In this case, we're going to end up with x minus 5 and x minus 1. Now let's cancel out common factors. X minus 5 and x minus 5, those two factors occur on the top and the bottom, so they can cancel out. Now all I have left is x plus 3 on top in the numerator and x minus 1 on the bottom in the denominator. Can't cancel it any further because remember we can only cancel factors, not terms. So we're done, and we can say that this is our final simplified fraction. Alright, so this is the last one I want to look at just because it has some tricky factoring in it. If we look at the numerator, that's a trinomial, but it's not a trinomial I can factor right away. I can't start going what multiplies to be 30 and adds to be 36. So before you go straight to factor by grouping, I want you to look for a greatest common factor. Is there something that goes into all three terms? It has to go into all three of them, not just 2 of them or 1 of them. In this case, there actually is. It's 6. 6 divides evenly into 6, 36, and 30. So when I factor out the 6, I'm going to be left with n squared plus 6n plus 5. Now in the denominator, that doesn't factor anymore, so I'm left with just n plus 1. Now don't think you're done yet, because we're not done factoring. Factoring is always the first step, and you have to fully factor both. So I need to go a little bit further. I already knew that I had 6, so 6 is going to stay there. And I already factored the denominator. Really, there wasn't anything to do. It stays n plus 1. I can factor that trinomial a little bit further, looking for numbers that multiply to be 5 and add to be 6. So we end up with n plus 5 and n plus 1. Now let's cancel out common factors. I see that I have an n plus 1 in the numerator, n plus 1 in the denominator. I can cancel them. That's it. So now let's look at what we have left over. We have 6 times n plus 5. We have nothing in the denominator, so I'm just going to write over 1. We can leave our fraction like that, but usually correct mathematicians know that anything over 1 is just the numerator. You can write it like that. So our final answer is 6 times n plus 5. That's our simplified rational. Don't be tempted to distribute that 6 back in. We like our rational expressions to be factored. You're going to see in some of the later activities that we do that having the factored form is really beneficial. It tells you different things about the rational depending on whether you're using it to add and subtract, whether you're using it to solve, or whether you're even going to try to graph it. So leave your answers in fully factored form. This last slide is just a little recap. We did the same thing in every single problem. That's what algebra is, doing the same thing over and over again. It's all about procedures. We learned our procedure for factoring and simplifying rationals. To simplify rationals, the very first thing you need to do is factor both the numerator and the denominator. Remember that numerator means the top and denominator means the bottom. You have to fully factor these, so I should have the word fully written there. Very important. Then, once you have it factored, you can cancel out any common factors to reduce the fraction fully. And remember, when I refer to factors, I mean things that are getting multiplied or divided with each other, not adding and subtracting. So do not cancel out x's unless they are factors as opposed to terms. So that's it. Simplifying rationals, pretty not too bad. Really, the biggest hurdle for anyone is factoring. If you need some refreshers on factoring, there are a ton of really good factoring videos in the polynomials playlist.